Hello. The topic for today is the concept of identity or the identity predicate and its usefulness in definite descriptions. So we're basically refining and adding on to how to use our language P to best reflect natural language. As you can see that P is very versatile, it's very flexible, and it can be used to cover all manner of sort of odd cases that S couldn't possibly cover. So let's add to our language P a little wrinkle. We're going to call it the identity predicate. Um, and so before talking about the identity predicate and how it works with P, we want to talk about identity itself. Like, what is it that we're actually making a predicate for? What are we symbolizing in our system here? And so identity, a rough and ready definition of identity, is the relation that a thing bears with itself only. Okay, and so there's exactly one thing in the world that is identical to me, and that's me. There's exactly one thing in the world that is identical with my phone. It's my phone, right? There is one thing and one thing only identical with my mouse, and it's that mouse, right? I mean, so again, it's the relation that something bears with itself only. So when we say something is identical to something else, we mean it's the same thing. Okay, even if we might have more than one name for it or something like that. And so this is not to be confused with other usages of the word identity or identical that are common in English. So for example, in the phrase identical twins, we don't mean to say that we mean in this case qualitatively identical, not numerically identical, right? You can't have two people be identical in the sense that we're concerned with here. Because there'd be two of them, right? So the idea is, if I point to, like two apples on the table, I was like, how can you tell that those two apples aren't the same apple? And he was like, this is a trick question, because there's two of them, right? No, if there are two twins, right, which there have to be twins, they cannot be identical in the sense that we're after. So the use of identical in that context is really, instead of identical, they should really say exactly similar. You should say we're exactly similar twins, not identical twins, right? And still less the phrase identity politics, right? So a lot of times people talk about how they identify themselves, right? Or that they talk about a particular kind of identity, whether that be historical or some other form of group identification. Again, that has nothing to do with identity in the sense in which we're going to be instantiating it in language P. Okay, in language P, we're only concerned about the kind of identity where we're talking, when we say two things are identical, we're saying that what that means is that they're the same thing, right? That there aren't two things at all, right? There's really just one thing that perhaps is just getting referred to in more than one way. Okay, so that's the thing. I am identical with myself only. That's it, right? And so again, that's it. For some examples of that, the idea is, when we say something like Bruce Wayne is Batman or Bruce Wayne is identical with Batman, we mean they're the same. They're the same thing, right? There's not two people. There's one. Okay. Or Marion Morrison is John Wayne. That's a bit of trivia I really like. John Wayne is obviously a great name for an actor that played the kind of roles that John Wayne played, but Marion Morrison not so much. So yeah, John Wayne, great stage name. Good move on that one. I know there was a guy named Arnold Dorsey. He went by Jerry Dorsey for a while, and then decided, for professional reasons, to change his name to Engelbert Humperdinck, who was also the name of a classical German composer. But ended up being very good for him professionally. People tended to remember that for some reason. But anyway, like when you say Arnold Dorsey is Engelbert Humperdinck, and say it as fast as possible, right? What you mean is that they're one and the same thing. Those are two names that refer to the same individual. There's really one thing here, and that's there's not two things. Okay, so that's what we mean when we use the identity predicate. We mean to say, look, these two names here, they're names for the same thing. So the identity predicate goes this way. It goes blank is identical with blank. And we're just going to write it with an equal sign instead of a capital letter. That's the only real difference there. Earlier in the text, that's been written with a capital I, right? Blank is identical with blank, right? That's fine. But if you notate that with the equal sign instead of the capital I, you can do some other things that we're gonna want to do from time to time. And so that identity predicate, again, maybe it seems more intuitive to write A equals B. Some systems you do that with the identity predicate. I just decided to try and keep things more consistent in this system. Other systems do it my way as well, where yeah, you just have the equal sign in the place where a predicate would be, and then you have the constants, the individuals that go into that those places in the predicate where they would normally be. So again, it keeps as much consistent as possible. And so what you mean when you say equals AB is you mean that A is identical with B, right? That you mean that these two ways of referring to an object are really, they're referring to one and the same object. And so here's the other thing about the identity predicate. Any number of lowercase letters can be placed in the identity predicate, right? If you want to say John Armour, Will Houston, Lauren Payne, and Lawrence Doobie Jr. are all the same person, which they are. This is Lauren Payne is adopted dozens of pen names during his career. So again, if you wanted to say all that stuff, you could use an identity predicate with 4 places or more, right? You just say, equals A, B, C, D. That means A is identical with B, is identical with C, is identical with D, right? They all are just ways of referring to one and the same individual, right? So there's the identity predicate. And the reason that we want to go ahead and notate it instead of just treating it like any other predicate is because identity has some special properties that are very often relevant in logic, right? And so it saves a world of time and trouble to say something like just equals BC, right? And then we can just treat that as the identity predicate instead of saying, oh well, I BC and by the way, I is symmetric and reflexive and transitive, right? And then that'll approximate your identity predicate. That's a lot of work, right? You can just put an equal sign in there. And then once you have that on a tree, you can say, okay, look, if B is identical with C, then that means that wherever there is a C, you could substitute that sentence with a B in it instead. And wherever there is a B, you could substitute that sentence with a C in place of the B. Like, so that identity predicate allows substitution. Okay, so for example, take a look at this tree here. On this tree, we have, the idea is that you've got this conjunction here, right? That's been split up into, TAB, and this second thing, not TAC, and not, or B and C are identical, right? And then, of course, because that's a conjunction, you just split that up. It also doesn't branch into, not TAC and equals BC, right? B and C are identical. So ordinarily, if this was, like I said, if we were just putting a capital I in here, right, then this tree would just stay open, right? Because there's not something and its negation up on this tree. But this tree really shouldn't stay open, because here's the thing: if B and C refer to the same individual, then this TAB and this not TAC really should contradict each other. And so what we're going to do is we're going to substitute either this B for the C or this C for the B. Either way works. And then you'll see that the tree should actually close. And that's what it looks like. So the idea is that what you've done is we've sort of substituted the C here for the B because B and C are identical. They're the same thing. Okay, and so if it's true that A bears or A does not bear the T relation to C, well then A also does not bear the T relation to B because B and C are the same thing. And so what we've done is we've substituted the C for the B here and put it down here, and there you see that these two things are the negation of each other, and so then the tree in fact does close. So one of the things I suggest is when you make an identity substitution, you say put a little star beside the thing you're substituting and a star beside the identity relation, and then a little star by the result, just so that you can remind yourself. And it works. It follows the rules, right? It's sensible if you don't put the stars in there. But if you put the stars in there, you can be reminded of like where you got certain lines from, and why and all that stuff, right? It's I think neater and tidier a little bit. But that's the idea, is that sometimes you can do that. You don't ever have to do an identity substitution on a tree, but sometimes it can be very helpful. Sometimes it'll help you close out a branch that otherwise wouldn't close, or that would take a lot more time to close, or something like that. So be on the lookout for those. And so one of the other really good things about having an identity predicate is that it allows us to do something with definite descriptions that we pretty much just need to do. And so let's talk a little bit about what a definite description is first. Okay, a definite description is a phrase. It usually starts with the word the, right? That picks out one and only one individual. Okay, and so here are some examples of definite descriptions. the phrase "the smallest mouse." Well, there can be only one smallest mouse, and so whatever individual that is, the description "the smallest mouse" picks out one and only one individual, and so that means it can be represented as a constant in language P. You might say the third red balloon from the left, right? Well, I mean, that picks out one and only one object in the world. Or if you want to talk about the author of Cry Like a Grandmaster, which is a real actual book, you can Google that. That picks out one person in the world. Okay, so that's those are some examples, right? So these are all definite descriptions, right? And there are of course others in the textbook as well. So because, again, those phrases pick out a single individual, they can be represented by a lowercase letter in language P, as in some examples here. So if I say the only pen in the drawer is blue, right, we have the predicate blank is blue, right? And the only pen in the drawer is our lowercase letter P. Okay, if you want to say 1 is the loneliest number, remember 1 is also an individual. It's a single, thing. We can refer to specific quantities in our language by giving a subscript, a numerical subscript, right? So if n subscript 0, actually usually I'd say 1. I don't know why I put 0 there. I think I was just not thinking. But anyway, I was looking at the letter O and thinking that's what I was doing. Okay, well, so yeah, I mean, why not just sort of edit that? Let's do. No use re-recording a whole video for that. Okay, so yeah, it equals n sub 1 and L, right? L being the loneliest number, okay, and then 1 being n, sub 1, right? And so then this equal sign is the identity predicate. So 1 is the loneliest number. We're saying that the loneliest number and the number 1 pick out the same individual in the world. So that's how you can do that. If you want to say the best baseball player, again, there can only be one of those, plays for Atlanta, right? Atlanta is an individual, right? You have to refer to that specifically. And the best baseball player, right, is going to be B here. And so we want to say blank plays for blank, right? The best baseball player plays for Atlanta, right? So there you go. Again, those are how to use definite descriptions if you're just going to, in the simplest possible way. But as with many things, sometimes the simplest possible way doesn't work. Sometimes it does, many times it does, but sometimes it doesn't. And so we're going to see a kind of case in which it doesn't, right? And then what we do about such cases. So for example, we'll see a kind of puzzle here, right? So here's our puzzle. If you take a look at this inference that's written here, it says the world champion of chess hosted the Magnus Carlsen Invitational. That's a chess tournament, an online chess tournament. Therefore, okay, so if that's true, then this other thing is true. Therefore, someone is the world champion of chess and the host of the Magnus Carlsen Invitational, right? So think about that inference for a second, right? If the world champion hosted the Magnus Carlsen Invitational, then somebody is the world champion and hosted the Magnus Carlsen Invitational. That seems as clearly valid as anything. But of course, let's check it in P, and I think you'll see what always happens when we're like, oh, that's clearly valid. Let's see if P says so, and we're like, Okay, so again, we're going to use H as the predicate blank hosted blank, right? And we're going to do as we did before, use this definite description, the world champion of chess, because that picks out one and only one person. Except for controversially a period of time in the mid-90s when the actual world champion Garry Kasparov sort of split with FIDE, and there's like a split world champion, like or an official and an unofficial or whatever. But it was Kasparov the whole time, okay? And so then for M, we're going to talk about that being the Magnus Carlsen Invitational, right? So that's, again, a definite description of a specific tournament, and that's picked out by one thing in the world. So yeah, that's how we're going to do that. Notice the Magnus Carlsen Invitational, we're just going to say that's just a tournament, right? Even though it begins with the word the, it's not exactly a description, okay? And so symbolizing that into P, we've got, the world champion of chess hosted the Magnus Carlsen Invitational, right? Great, HCM. And that entails, with the now correct double turnstile, that there exists an X, that is someone, okay, is the world champion of chess, right? And hosted the Magnus Carlsen Invitational. And honestly, that ought to be valid. But if we check a tree, right? So here's the tree for that puzzle in P. And we notice that two of those branches end up open. I wanted to point something out about the way that this particular tree works. So notice if you're super alert on this one, or sort of pause this and are like really poring over it. If not, pore over this one. See what seems to be a little funny about this. And if what seems to be a little funny about this is, why is this branch closed? Again, give yourself like a little logic plus point or whatever in whatever notebook you're keeping track of this, because you should absolutely be wondering, why is that branch closing? Well, the reason that that branch is closing is because, well, because this has got to be a contradiction, okay? What we're saying is it is not the case that C is C, right? I mean, that's a contradiction. It's a violation of the law of identity, and which is a contradiction. So it's not a contradiction in the sense that we've been used to looking for it, and perhaps I shouldn't close that branch off, and it doesn't really matter because other branches are open, but I couldn't just leave that unclosed with something like that on it. Says that it's not the case that C is C. So if you do see that on a tree, go ahead and treat that as a contradiction. That's because it is. All right, so essentially this puzzle that we have in front of us, there's actually a much older puzzle that Bertrand Russell, who was one of the people who developed the system of logic that we're, or a relative of the system of logic that we're studying. This is a part of the trouble that Russell himself dealt with. And in fact, you might say one of Russell's most valuable accomplishments is that he wrote like a big long, sort of treatise on the word the. And that sounds really trivial, but that's effectively what's going on, because he managed to figure out how to handle some real problems with definite descriptions by using a system of logic very well, right? So here's what he came up with. So, and here's the older puzzle. Here's the way it works. So consider the sentence, "The present king of France is bald." And let's consider putting that in language P. Again, if we're doing it the simple way, which we know isn't going to work all the time, it's just lowercase k for the present king of France, and then blank is bald for the predicate be, right? So the present king of France is bald. There we go. And of course that's false, okay? Because there is no present king of France, right? So if there is no present king of France, then that king can't be bald. Pretty easy, okay? So if it's false, that means its negation must be true, right? Oh, whoops. Now we have a problem. Okay, but so it's not the case that the present king of France is bald. Isn't that also false? Again, because there's no present king of France, right? I mean, like, being not bald means having hair. And can you have hair if you don't exist? Probably not. So yeah, so it seems like the phrase BK and its negation, not BK, is they're both false. That's weird and weird. And so if BK is false, then its negation should be true, and they can't both be false, because then BK and not BK wouldn't be a contradiction, and of course that's a contradiction. So yeah, there's a problem here. We're doing something wrong with our definite descriptions in cases like this, where we're referring to things that don't exist, right? And even in other cases, like with the Magnus Carlsen thing, the Invitational Tournament, all that, the present, and the World Chess Champion, both of whom absolutely exist. That's a real tournament and a real person who actually is the world champion of chess. So anyway, here's how Russell solves the problem. Okay, so he comes up with this phrase here, which looks ungainly, but I've sort of color-coded it to make it a little bit simpler. It's really just a conjunction, right? Notice there's an and and an and. It's just a conjunction of three much simpler phrases. So the present king of France is bald asserts three things. First, it asserts that there exists a present king of France. Okay, that's this part here. There exists an X such that X is the present king of France, right? That's all that says. Then it says and, right? There's the and here, right? It asserts that there's only one such individual, right? That's what makes it a definite description as opposed to just a description. It's not, the guy in blue pants, right? Well, there's lots of those, right? It's, the guy in blue pants who is in this room eating cake or something like that. That's a definite description, right? If there was such a person, there would be only one. As it turns out, there is no such person, at least not, visible to me. And then, of course, this third thing, that individual is bald. Okay, so that's just X is bald. So notice all of this is in the scope of the existential quantifier here, because it has to be, because there's an X here, and there's an X here, and there's an X here. So all those variables have to be in the scope of their quantifier. And so let's see what happens when we try and apply this solution to, to the other puzzle, right? And so we would say that the world champion of chess hosted the Magnus Carlsen Invitational. Therefore, someone is the world champion of chess and the host of the Magnus Carlsen Invitational. Okay. So notice what we're going to do. Instead of representing the world champion of chess as simply a lowercase letter, what we're going to do is we're going to build that into the predicates a little bit here. We're going to say there exists an X such that X is the world champion of chess. Okay. And, right, if Y is the world champion of chess, then X is Y. That's another way of saying there's only one world champion of chess, right? And we're going to say and here, and that person hosted the Magnus Carlsen Invitational. So if that's all true, okay, that the world champion of chess hosted the Magnus Carlsen Invitational, the present king of France is bald, right? Same structure. Then that will entail that there exists some X such that X is the world chess champion and X is hosted the Magnus Carlsen Invitational. Right? Okay, so let's see how that does if we put it on a tree. And happy times, the tree closes nicely, which means, of course, that we've proven that the inference is totally valid, that the entailment relation holds just fine. Great. Okay, perfect. Which is good because, of course, Magnus Carlsen is the world champion of chess, and of course he hosted the Magnus Carlsen Invitational. He was the one doing the invitations. And actually, if you're interested, here are the standings of the Magnus Carlsen Invitational. They're not exactly up to the minute when you're watching this, but when they were recording, they were still playing a couple of games. So they got really pretty much today, and then I think tomorrow's action will be the end of the first part of the tournament. And so, surprise, surprise, the current leader of the Magnus Carlsen Invitational is in fact Magnus Carlsen himself, who is in fact the world champion of chess. So, so there it is, in case you were interested.